Hi, this video will explain what a Keptn SLI provider is and why one is required. This video will also explain service level indicators, the SLI file, and service level objectives, and the SLO file. You will see how to implement a Keptn quality gate from scratch using Prometheus as the SLI provider. We start from a default Keptn core installation. No other microservices have been installed yet. A project with one stage and sequence has already been created. A service called Service 1 has also been created. In other words, the most basic Keptn project has been created. The deploy sequence contains one task called evaluation. Keptn Core already comes pre-installed with services capable of handling this task. Run a sequence now and see what happens. We receive a warning informing us that we haven't provided a time frame for the evaluation. The Lighthouse service needs to know for what time period it should pull metrics. For example, the previous 1 minute, 5 minutes, 6 hours, etc. There are two ways to provide a time frame. You only need to do one of these. The first option is to provide it directly in the shipyard file. Do this by adding a properties block to the evaluation task with a key of time frame and a value of the time you want to pull. Trigger a new sequence and you should see a different error message. Before proceeding to fix this new error, we will demonstrate the second option to pass a time frame. Modify your shipyard file again and remove the properties block so you're now back to the initial state. Modifying the shipyard file is simple, but the downside is that the time frame is hard-coded. What if you want the time frame to be more dynamic? The second option is to pass the time frame in when you trigger the sequence. This is much more flexible. In this case, we use the data block. Convention here is to create a new JSON object where the key matches the task name. In this case, evaluation. Then add the time frame. Both options are equivalent, but I prefer the latter as it is more flexible. The new error message indicates that there is no SLI provider configured for the project. So what is an SLI provider? Right now, the Keptn Core microservices are installed and Prometheus is also already installed on this cluster. You can check what microservices are installed by showing the deployments in the Keptn namespace. Keptn Core is unopinionated about tooling. Keptn allows you to bring any observability platform you choose. In other words, Keptn does not understand how to interact with Prometheus. We need to install a new microservice which contains this logic. The Prometheus service is this microservice. It is an SLI provider because it knows how to retrieve metrics from Prometheus and return them to Keptn. This flexibility means you can use any metric backend with Keptn. Install the Prometheus service now and notice the new Prometheus service deployment in the Keptn namespace. You can also see this via the integration screen in the bridge. Keptn can use different observability providers per service and stage within each project, so we need to tell Keptn that for Service 1 in the SLI video project, we wish to retrieve metrics from Prometheus. Retrigger the sequence and we now see a different message. This one tells us that the connection to Prometheus worked, but Keptn doesn't know about any SLIs or SLOs. Notice that the sequence is successful, but Keptn defaults to a 0 score. Let's fix that now. Keptn needs 3 things for an evaluation to work. Number 1, which observability platform should provide metrics? In this case, we've already configured this to be Prometheus. Number 2, what metrics to retrieve, also known as the SLIs. We haven't set these yet. Number 3, what thresholds are acceptable for each metric, also known as the SLOs. We haven't set these either. Keptn allows users to provide different SLIs and SLOs per stage and microservice. This makes sense as you probably have different metrics and thresholds from one environment to another. You definitely have differing metrics for each microservice. Navigate to the dev branch and go into the Service 1 folder. Create a new folder called Prometheus and inside, create a file called sli.yaml. The folder and file name must match exactly this as the Prometheus service relies on these names for the lookup. The SLI file is the list of all metrics that you want to retrieve from your observability backend as key value pairs. You decide the keys, and the value is provided in the platform-specific syntax, in this case Prometheus syntax. In other words, the SLI provider service will read this file to understand what metrics you want to achieve and what query to run to retrieve them. Different SLI providers will obviously use their own syntaxes in the value portion here. In this file, we're pulling two metrics from Prometheus that we've chosen to call scrape time Q99 and scrape pools failed. Save this file and navigate back to the service1 folder. At the root of this folder, create a new file called SLO.yaml. Again, the name is important. Conceptually, think that by now the Prometheus service has pulled the metrics. Now add thresholds and acceptability criteria. Start by adding a comparison section. Keptn automatically stores the result for every evaluation. Use this section to define how new evaluations are compared against old ones. Here, you're telling Keptn to look back through the history for this project, service, and stage combination and find the previous passing build, ignoring failed builds, and only pull the average results for one previous build. Next, add an objective section. This is where you define the objectives for each SLI. You do not need to use every SLI that is defined in your SLI file. Your SLI file could define hundreds of metrics, but you choose to only use a handful here, and that is fine. Start by listing each SLI. Notice the name must match what you used in the SLI file. Finish by adding a total score block. Keptn will score each SLI as a pass, warning, or fail individually. Keptn will also combine these scores to produce an overall build score. The thresholds here define the overall pass, warning, or fail build results. In other words, if the overall build score is over 90%, the build will be marked as a pass. Between 75 and 90%, the build will be in a warning state, and below 75%, the build will be marked as a failure. Both scores are useful. Individual SLI scores tell teams what needs to be fixed, but perhaps the build can still proceed even with a few bad indicators. The overall build health may still be acceptable. Blocking or progressing a delivery pipeline should rely on the overall build result of pass, warning, or fail. Execute a new sequence. Notice that the evaluation now works and we receive metrics. The build score is a perfect 100% and the build passed. Thresholds have not yet been added, so every build will pass. This is useful as you can experiment and add metrics first before defining thresholds. Now add some thresholds to the SLIs. In this case, we tell Keptn that the scrape pools failed metric should be considered a pass if the value is less than 1. Save the file and execute a new sequence. Notice that now the metric has a score. The build also has a score and a result of pass. When only the pass condition is added, the SLI can be in one of two states, a pass or a fail. Extend the objective to add a warning state. Increase the pass threshold to less than 5 and add a warning block of less than 7. Now, if the scrape pools failed metric reports less than 5, it is a pass. 5 to 7 means the SLI is in a warning state, and above 7, the SLI is failed. Relative thresholds are also available here for regression testing. We could say less than plus 10%. When Keptn compares to the previous build or builds, it will allow up to a 10% increase before warning or failing. In other words, not every metric has to have a static threshold, and you can allow for environmental fluctuations. Save the changes and run a new sequence. Notice the new warning threshold. The scrape time Q99 metric reports a value of 60. Add a pass criteria to the scrape time SLI, which will cause this metric to fail. Save the file and run a new sequence. The build now fails because one metric passed and one metric failed. Therefore, the build score was 50%, and the overall build pass threshold is set to 90%, so the build failed. However, what if one metric should be considered relatively more important than the others? SLIs can have weights assigned to them which influence their scores. By default, SLIs all have a weight of 1. Here, we're declaring that the scrape pools failed metric is 3 times more important than the scrape time SLI. Save the file and run a new sequence. Again, one metric passed and one metric failed, but rather than being a failure, the build overall is now in a warning state. That's because the passing metric was more important, or, said another way, the failing metric was less important due to the weights we assigned. This concept allows you to fine-tune the SLO file to reflect your unique environment and configuration. Finally, imagine an SLO with tens or hundreds of SLIs. What if one metric is so important that regardless of the other metrics, if that one SLI fails, the entire build should fail? Imagine security vulnerability metrics or business metrics like a broken checkout button. Just like the weight parameter, Keptn offers a key SLI field which does exactly this. The build is currently in a warning state, but let's declare that the scrape time metric is so important that if it fails, the entire build should fail. Save the file, rerun a sequence, and notice that the build again fails. This is because we marked the scrape time SLI as a key SLI. So if it fails, the entire build will fail, regardless of the result of the other SLIs. This video has explained Keptn SLI providers and demonstrated how to build a quality gate using Prometheus and Keptn. I hope you found this useful. Thanks for watching.